When you look out into the starry sky, do you ever wonder what's in the void that fills the universe? You would probably say to me, "Oh, it's just empty space," to which I would tell you that you're wrong, and that particles can come in and out of existence from absolutely nothing and without cause, therefore meaning that a perfect vacuum can never exist. Before you start a rally to get all physicists burnt at the stake, let me hopefully give you a glimpse into a principle that is fundamental in explaining the formation of these virtual particles. You can think of the uncertainty principle like this. Let's say that I chuck a tennis ball at a wall, and you are observing me from the side. At any moment in time, you can look at the ball and know exactly where in space it is and where it is going. Of course, the quantum world just refuses to follow common sense and says, if you look at a particle you can only tell where it is going or where it is, you can't know both. While position and momentum are two complementary variables that are easy to understand, the uncertainty principle covers all sorts of other complementary variables such as energy and time. The thought experiment that was used to come to this conclusion can be thought of like the following. Firstly, we know that light can act as both a wave and a particle thanks to Young's double-slit experiment and Einstein's photoelectric effect. We also know that the least obtrusive way to observe an electron is by seeing, which is done by bouncing a photon off it. If we want to know with precision where an electron is likely to be, then we need the light wave to be localized, which is achieved by using a small wavelength, and thus a high frequency. Unfortunately, high frequency means high energy, thanks to this equation. As a photon bounces off the electron, energy transfer takes place, therefore changing the electron's momentum. We could reduce photon energy, thus reducing the disturbance, but lower energy means lower frequency, and thus longer wavelength, leading to a less localized photon, therefore making a measurement of the electron's position less precise. This thought experiment shows a trade-off between our ability to measure a particle's position and its momentum simultaneously. While it may seem like the only reason we can't measure position and momentum simultaneously is because we still use light to observe stuff like primitive barbarians, the uncertainty principle states a property of quantum systems and is not a statement about the observational success of current technology, meaning that Heisenberg only explained it to us using light, because the mass behind it makes normies like me want to become artists. Now as to how this principle gives pulling things out of nowhere a whole new meaning, that is something that builds on our inability to measure simultaneously, and to a high precision both a particle's energy and its time in a certain state, which is a topic for another video.